Alright, let's get my whole face up again. Hello, I'm Tom Marks, I talk about code. Welcome to another Rust live programming stream. Today, we're going to be doing more fantastic Rust stuff. We're going to be fleshing out my 16-bit virtual machine. We're going to be adding more instructions. We're going to make it do cool and interesting things beyond just adding numbers together. I am quickly going to dump this link into my Discord, and then we are going to go live. We're going to go hard. It's probably going to be my last YouTube live stream. I'm going to go back to Twitch after this because I think it will be better. So I can see my chat. I can see myself. This all looks good. Let's do some code. I'm going to make a branch today. I'm going to call this branch more instructions. Or not. I'm going to call it more instructinos. But that's okay as well. I think that's funnier, actually. So, last time we made this cool, well, the last several times we made this cool derive macro that means we just dump in a bunch of instructions and what data they operate on, and all the encodings and decodings get auto-generated for us, which is cool, which is really cool. And we can use this we can run our virtual machine on some test program and get an expected answer. Now, I probably need to clean up all of this dumb output, right? That's probably not the best. Damon, good morning. Damon, I don't know why I said that like it was a Star Trek thing. Interesting reference. Okay. But yeah, so I probably need to think about how we're outputting this stuff because I'm going to have to start writing test cases. But for now, let's just dump some more instructions in here, okay? We add instructions and all of the wiring gets auto-generated. The only thing we need to implement is how the machine actually interprets it, which is really cool. Our assembler knows what to do. Okay, so let's start with an unconditional jump. Now, jumps are interesting because well, we can choose to either jump by an offset, well, jump by an offset or jump by an absolute address. And let's actually call this jump rel, and we're going to give it a byte. That's not a huge range to jump, all things considered. So we're also going to add... Actually, no, I'm just going to... Okay, yeah, I'm gonna add two variants in this. I'm going to have one that operates on an immediate and one that operates on a register. Or is this a immediate, literal? I'm going to go immediate. I'm going to formalize now immediate. We need to give these opcode values. Let's dig into this hex 40 range for our control. Okay. Absolute jumps are interesting. Absolute jumps are cool. Oh, relative jumps, sorry. Jumps that depend on where our program counter currently is. We're also going to add a jump absolute. Actually, you know what's interesting here? What's interesting here is this is all unnecessary, and I'm actually making life much harder than it needs to be. Because I've defined our program counter just as a normal register, jumping the program counter... We're going to need one special jump instruction, but jumping the program counter is actually just adding and subtracting. What we need here is a branch, and... Oh, you can only see my face. No, 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 no. Why have I done this? Oh, dear. Okay. That's also the wrong scene. Cool. Thank you very much. This is why I love having a chat to tell me when I've been silly. All right. This is going to get... All that's going to get edited out for YouTube, so that's great. Let's think about this. What am I saying? Okay, so for anyone watching the VOD of this, I was just talking about how I'm going to add new instructions, and it's just as well because I got a little bit confused with what I was talking about. We can actually do some form of control flow, and let's actually write a test program to demonstrate this. We're gonna have to start, being a bit more formal about how we test this machine. But let's have a look at this. Okay, so let's get a split up, let's get our ops up. Some of this is still a bit exploratory for me as well, but we can actually operate on the program counter, right? So I was gonna add a bunch of jump instructions, but they're actually unnecessary, except for one special jump that we're gonna need. So let's try writing this. Let's maybe say So, the other thing that would be fun to do would be to have a add immediate to register, because then we don't have to do this silly dance. My goal is, so our program counter starts at 0, right? 0, 1, 2, okay. So, push, push, we can add 10 to the program counter. We can add anything to the program counter. Let's maybe say 3. Or, no, this has to be... So, our program counter increments by 2 because all of our instructions... Like, the program counter points to a byte. Our memory is byte addressable, but our instructions are 16 bits. So, we need to do everything multiples of 2 here. So, this is program counter 0. This is program counter 2, 4, 6, 8, 10... so let's maybe... And then we're going to signal whatever our halt signal was, which, if memory serves, signal halt. And I think, I actually can't remember what I decided. Oh, this number parsing. Okay, yeah. $sign means hex. So something like this, right? So, we want to, what I'm basically trying to show here is that I can skip an instruction. So add register PCA. So we want to add, there's another interesting thing here, right? So this is a bit cumbersome, trying to manipulate the program counter like this. We're going to need to have some kind of like pseudo instructions or some kind of macros that's going to make this easier when we're writing actual programs. But for now, this kind of works. When do we increment the program counter? This is... Okay, so we increment it right away. So we want to only add 2. Let's try this program. Jump test jump.prog. Panicked. Because we need to pipe that to a file instead. So what is going to happen when I run this program, by the way? Probably important to mention. So I'm expecting it's going to load 20 and then 40, and we'll see that the value of 60 ends up in register B. But actually, let's make these hex numbers, because all that output is actually in hex. If this jump does not work properly, we expect to see hex 70 in register B instead of hex 60. So we're basically saying skip this instruction because we're just going to add to the program counter. Manipulating the program counter in this machine isn't special, isn't privileged. We don't need dedicated jump instructions because we can just mess with the program counter ourselves. Okay, so cargo run bin VM test jump dot prog, and we can see that something strange happens, something unexpected happens. Let's look at this whole trace. So we push number 2, which is good. We pop that into A, which is good. We push 20, and then we add A to A, which is not correct. Oh, and that makes sense, actually. Does it? No, that doesn't make sense. What's happening is we're adding A to itself, and then also when we pop B, we're actually popping A. So this problem, I have a hunch. If we look at our register file, we have this good register from string function now. You would expect that this works, but for some reason it always gets back. So for one thing, this is actually unnecessary. We can just cast this. I don't want to get too many things tangled up in these changes unnecessarily, but A, B, C, M, S, P, B, P, P, C flags, that looks fine. A, B, C, M, S, P, B, P, P, C flags, that is also fine. What does the assembler do? The assembler now just calls instruction from stir. What does instruction from stir do? Instruction from stir decodes the instruction, and this all lives. Oh, I refactored this, by the way. I refactored this to look a little nicer. So let's look. This is the instruction format, right? Where one register or two registers from stir. Register from stir, which appears to be implemented correctly. So that's okay. So the encoding, the mapping from string to instruction looks correct. What about the encoding of the instruction as, well, that's here as well. And so this is why I did this refactor, by the way. Bobius, by the way, good morning. I can't remember if I said that. This is why I rewrote it like this, because I can say, here's an instruction that takes one register as the thing it operates on. Here's how it gets encoded. Here's how it gets decoded. Here's how it gets turned into a string. Here's how it gets converted from a string. It's all just here, so I don't have to do any scrolling. And it deleted like all the replication, all the duplication in this file. If you're confused, this is the macro stuff that generates all the things. It's fine. It's fine. Register from U8. So when we encode it, we convert the register to a U16. We bit mask it because it's only 4 bits, and then we shift it left. This looks right. There's an interesting suggestion from Damon in the chat. We will get back around to this. So if I do this now, by the way, I think it's going to break because we don't have from U8 anymore, but that's okay. Oh wait, from U8, that's not... No, I did need that, did I? I can't remember. But anyway, that's not the problem. That's not what's going wrong here, I don't think. Let's just not touch this for now. I'll loop back around to it. So I've changed nothing here, and we're going to get the same issue. Decoding. This feels right. This feels right. Because you can see these things are mirrors of each other. Is it the encoding or the decoding? Okay, well here's an easy way to show this. We're gonna copy our assembler real quick, and we're gonna write a disassembler. Now this isn't quite the same. But it's gonna be close enough. Now this isn't right. This is actually gonna be more like our virtual machine. Yeah, excellent. Excellent, okay. Okay, here we go. So we're going to write a disassembler. We're going to look at what is actually in the binary. Because that's just going to be easier to see and easier to iterate on. And this is something that I think we should have just done anyway. Something we should have just done anyway. Yeah. Okay. Reader program. So for what do we? Okay. This is where I want to cast this. Not really like this. Yeah, this is what I want. I want to interpret transmute many. Safe transmute. So I can do some kind of transmute. Now the alignment is probably okay. This is probably fine. I just really suspect that this won't align a vector to a weird byte boundary, even though it's a vecuate. I have that suspicion. If I was to slice this vector and then try and transmute it, then to a vec U16, then probably not. Oh, hold on. Okay. Copying the section. Right. Read method on open file directly together with a fixed site. Here's the other thing, right? Is there a method that will just do this? Is there like a collect or something that'll do this? Damon? Anything here? Yeah, okay, yeah. So I just want to interpret it as a slice of U16. So I want to be able to say for, let's say let, and I want this to be a slice of U16 equals something. Let's use a whole. Then we're just going to print out, and it's going to be the instruction. It's going to be instruction from stir. But I probably need to do this outside of here. So let instruction from. Oh no, sorry, hold on. What, that's not right. That's also not right. This isn't a string. This is a from. What am I doing? Man, it's one of those days. Hey, it's a try from. So yeah, we want to get it as an instruction, and then it's value dot. Well, maybe just value. See if we can just stringify it like this. That should hopefully make sense. Align to. Okay, align to. I think I used this before, but in a really janky way. Align to. That doesn't have it. I just want a good example. That's also not this. Okay, let's get rid of the word cast. Align to. Okay. So we want to say let where did I align to program dot align to. I think we have to borrow the program align to U16 Okay, let's see if that works. We have to add this as a binary target in cargo.toml. Cargo run bin. Okay. Result doesn't, oh, it doesn't implement display, of course. This is because I've done this strangely, actually. Format. Implement display for instruction. Instruction, yep, okay. I was looking at this, I'm like, I'm pretty sure I did implement display for instruction. I'm pretty sure I had this like meltdown last time. Okay, yeah, here we go. This is because I have not unwrapped the result. Okay. Cool. Use stdio read. Lots of warnings. Cool. Yeah, I think it's just a slow day today, you know. These things sometimes happen. Oh, yep, I forgot that you can't just do this. You need the freaking double colon, which we all love. Every Rust person enjoys having to write double colon. Buff read write. Unused import from stir. So we just have to get rid of all the faff. Reference to reference of U16 is not an iterator. Try from call to unsafe function. Okay, so this is it. This is the only other thing we need to do. Just say this is unsafe. Trust me, it's fine. Now we just need test jump.prog. Okay, excellent. Excellent. So now we can clearly see that when we decode these, it's incorrect. The Turbofish, that's such a good name. I love this. Is that the canonical name for the, like, because it checks out, Turbofish, yeah. I don't know, the Hebrew scope operator from PHP. What? There's a joke here I don't understand. That makes me nervous. Okay. Turbofish, however, fantastic. Fantastic. Okay, so I've got to think about this. Well, okay, here's the other thing that I should do just to really do my due diligence is have a look at the actual bytes here and try and work out what's going on. So I've got to think about these encodings. Let's maybe get up the actual code, jump asm, then we're gonna split, we're gonna open a new thing, which, so I didn't actually need to split. We're gonna use my favorite command R. This isn't necessary, but I'm gonna do it this way because it's easier to show. Test jump.prog. Excellent. Excellent. That's a disgusting format, but we'll take it. Let me just clean all of this up so we can just focus on the bytes. Annoyingly, there are just 2 bytes too many to fit this all nicely on. Well, I mean, actually, now that I've taken over, I can do this. Okay. Each instruction is 2 bytes, so we can put these nicely on a line each. And let's see what is going on here. Bobbius, if you posted a link, no link came through. I cannot see a link. YouTube has assumed you're a bot. Okay, so instruction 1, push with the value of 2, excellent. Pop register A, excellent. This is what we want to see. Add register, okay. This, now we can see the cracks, right? We can see what's gone wrong here. Add register instruction, which is hex 21. Let us just confirm that this is correct. Add register hex 21 takes 2 registers as arguments. We can see that it has been encoded. Both of these registers are 0. Now, thankfully, register 0 is just A, right? We have a sensible default here. However, we do not get the correct register for the program counter. The program counter we would think would be 0, 1, 2, 3, 4, 5. We should expect register 5, but we don't see it. Why not? Why not? Let's jump down to where this gets encoded. Let's get rid of that split because that's annoying. Okay, encoding. We get the register as a U16, so we cast it from a register to a U16, and Rust says, yeah, I can do that because this is just an enum. It's just a U8 under the hood. We then do an AND, which should be fine. Like there aren't that many. Oh, the link went in Discord. Okay, I'll get around to that. And then we left shift. We already cast to a U16, so we're not shifting out of bounds. Okay, what I think we need to do, I'm just gonna really grossly hook. Sometimes you just need like to print some dumb stuff out. So let's go let R register A. Actually, this is a perfect... What am I doing? This is the perfect time to write a unit test. I have not done this. Rust unit test. I've seen Rust unit tests. I have written a Rust unit test. I'm lying. But let's do this. Okay, so what we're doing is saying that when we're building in test mode, this code exists. And Rust will just know what to do. Mod test. This is a cool idea. We just import everything that was available in the outer scope. Test. Test. Encoding. Test. Yeah, let's say test encoding. That's good. That's good. And then we have an assert macro. We're going to assert that. Register A is 0. We're going to assert this, right? Because if this changes, we want things to break kind of violently. Now, we want to be kind of careful. ABC, SP, PC, BP, flags. We don't want to write too many tests that depend on exact encodings of things, but we want to also know that we're doing this kind of properly. Also, interestingly, this only needs 3 bits of information at the moment, so unless I add more registers, I can eke a little bit more space out of my instruction set somewhere. So let's say cargo test, if I can type properly. Yes, and this makes sense. Cool. And this looks okay. Okay, that's good. That's good. So then what? So then something's gone wrong when we do this mask and shift. Hold on. There's a link in Discord. While I ponder this even more, what is this? This is real. What the hell? What the hell? Who wrote this? I still don't get it, but that's hilarious. It's Hebrew for double colon. There you go. I love that. I love that so much. You know, not everyone who writes code is an English speaker. It's a very English dominated world, but yeah, there's other stuff out there. Okay, let's go into our file that defines ops, and let's write some tests for the magic that we're generating. Because that sounds like a really good idea, right? We're generating all this stuff. We want to actually probably have some kind of confidence that it works. So let's write a test called test encodings, right? And so we're just going to do the dumbest thing possible. We're going to say assert EQ. We're going to assert that push. Let's do the big one. Let's say sub stack, and that should be equal to hex 22 as U16, right? Nothing complicated about this one. There's nothing to encode. Let's say push. We need to prefix these with a... Actually, I can probably just say use super instruction. Can I just do this? And so then I don't have to namespace them. Anyway, let's see if this works. Push hex 5. So then this would be 0522. Yes? No, cannot be applied to the type instruction. That is fine because we have implemented into... No, we have. We've got a function called encode U16, which probably should be something else. But also maybe not. I don't know. This might need a bit of cleanup. Okay, there we go. Super apparently unused, that's fine. Test encodings fails, it blows up. Because these numbers are wrong. Line 50. So this one blew up. This one wasn't correct. This one wasn't correct. Interesting. Okay. Annoyingly, these numbers are not in hex, so let's just quickly hexify them. 1281 1314. Oh. This is so silly, right? Do you know what happened? I used the same opcode for push as substack, even though these do not have the same opcode. Let's rerun cargo test, and now everything's okay. Beautiful. So then the big one, right, the spicy one, let's say add register b register. Let's add something to the base pointer because that's spicy. So this is going to be... So the second register goes at the top. What did I say BP was? I said BP was 6. So it's going to be 6.1 hex 6.1 and then add register is 2.1 as U16. Okay, so this is going to fail. This is going to fail, and this is good. It's going to fail because we didn't write it properly. Okay. Now it fails for the correct reason. Because it just turns into 0021. Hex 21 is 33. That checks out. Yeah, cool. Because it's 32 plus 1, of course. So where have our registers gone? And this is good because now we don't need to worry about compiling and rerunning or anything. We can just run this test, and when this test passes, we've fixed the bug. Okay. So, and we know the problems with the encoding, not the decoding. So that's good. This lets us narrow down. This lets us narrow right down. Now we can just try some different stuff, right? Register. Okay, so when we encode this dereference shouldn't matter. That's fine. As U16, Good old using Python for bin to hex. There's no better tool, in my opinion, than just opening up a quick Python REPL when you have to mess around with some numbers. We cast it to a U16. We can't possibly lose anything when we cast this to a U16. That doesn't make sense. Let's just get rid of this mask for now, because that makes me nervous. But you can always left shift. We left shift it by 8. That's fine. It's a logical OR. That's fine. Let's see. Oh, well, that also actually doesn't change anything because I need this one. So let's do the same thing here. Let's get rid of the mask. And that works. Okay, so for some reason, masking this down to 4 bits causes it to blow up. But oh no, it's this bug again. This, every time, okay? Seriously, this hit me last stream. Just wrap your masks, just be prophylactic. Don't let there be any room, because what's happening is we're bit shifting this by 8 and then masking, and of course, you know, FOO, this is only a 4-bit number. This is only between 1 and 16. If we're masking it with FOO, of course it's 0. So, yeah, at M, left shifting the mask happens every time. It really does happen every time. It's insanity. It's so easy to do. Okay, so cargo test, that now works. Let's say cargo, we have to run the assembler again. Jump.asm, we're gonna pipe that to test jump.prog, and now we're gonna run the virtual machine with the program, and we see that 9.6 ends up in B. Is this hex? Is this in hex? This isn't in hex. Okay, so back to Python. This should be 6.0. Yeah, and again, that makes sense if I was thinking about my 16 times tables. But anyway, that's the correct answer. Because if we go all the way back to our program, right, what we expect it to say is add 2.0 to 4.0 and then store that in B and die. If this line gets executed, then that won't be the correct answer, but it doesn't because we add 2 to the program counter here, effectively skipping an instruction. So we can do these relative jumps. We also need to be able to do absolute jumps, which would mean setting the program counter to something, but we can do that from the stack with pop register SP. For example, let's continue this test, right? So we have a number in B. Let's say push 90 sub pop register A sub register BA. So subtract A from B. No, subtract A equals A minus B, right? Substack A equals subregister. Register 1 equals register 1 minus register 2. B equals B minus A. Yeah. So if we make this correct, and actually, sorry, this is 6.0 or 96 or hex 6.0. We're gonna keep working in hex because that's easier to read. Push proper subregister. Bobby has asked what the plan for conditional jumps is in chat. I'm gonna do that as soon as I have a good example of unconditional jumps working. So this should be zeroing the B register, but before we do this, we're gonna say, so hold on, so this is the other thing that's important, right? So 0, 2, 4, 6, 8, I can just, so I wanna jump straight to line, well, I need to do this first, pop register PC, right? So we're just gonna load some value directly into the program counter. Now, we want to jump straight to hex to 30, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6. We want to jump straight to 28, I think. That would make sense. Okay, we didn't jump to the right spot. Oh dear, we jumped very much not to the right spot. Maybe that was one too far? Yes. 26. Yes. But then we should also do something else so we know that something actually ran. So let's maybe say push. Right, and we just load something random into some value so that we can see that C now has some random garbage in it, but B also was not zeroed out. That's cool, that's cool. Okay, so we know that relative and absolute jumps are fine. What did we actually change there? we fixed the instruction encoding. Excellent. Okay. Now let's actually add a new instruction. You know, I've demonstrated that I don't need to add those jump instructions. That saves us valuable space in our opcode realm. Conditional jumps. So let's add a branch instruction. Okay, so how branch is going to work is, we have this wonderful register called, and I'm making this up as I go, by the way. I don't actually have a concrete plan for how this instruction set's going to work. I'm just going to do stuff and it's going to be fine. We have this cool flags register. What I'm going to say is branch is going to be a lot like a jump, and this is going to be where we crack into this hex 40 range for opcodes. Branch is gonna execute, like it's going to update the program counter only if flags are set according to some thing, right? So let's say branch im so and there's two ways we can approach this, right? One is if let's make it simple, right? Let's make it simple. One bit of our flags will be it'll be called test, and we'll have conditional instructions. So we'll have an instruction saying if 0. Okay, so these two things together will let us do a lot of things. If 0 we'll implement in a second, but if 0, if the last comparison operation we ran was true, then when we run a branch we will execute some jump. Otherwise we will do nothing, we'll just skip it. And branches will be relative. This also has a lot of implications. A lot of implications for writing compilers. I guess we could also say opcode, let's go. And we could probably also say have branch register abs, which will jump to an absolute address rather than a relative one. Maybe all register branches should be absolute, actually. I don't know if there's much value. Yeah, okay. All register branches will be absolute. I'm calling it right now. If flag and we're gonna document this. We're gonna document this. Equals because I just don't think there's that much value. I don't think there's that much value in relative branching based on a register. Just kind of imagining what a compiler would look like. Yeah, and you've got options, right? Like if you want your immediate to actually be absolute, you can always just load it into a register. Uh, this is fine. This is fine. I don't think, I don't know. Relative branching is weird. So let's do my old favorite cargo build, and we'll see that some stuff goes wrong, and that is because we haven't implemented these instructions. So we're going to come in here, instruction. Let's do if first because that is very good, and this is going to work, yeah, on a register. So if the register is 0, then we're going to say self.registers. Let's say self.registers the flags register or equals register and we wanted to find these as some kinds of like constants, right? Maybe this needs to be its own type. Maybe we need some kind of type pub. And we'll say something like, yeah. Bobby, as you're heading off, thank you for stopping by. Thank you for chatting. Always appreciate it. Let's, yeah, register flags. Right, we're going to make this nice and hopefully simple. Right, but so we set a flag in the flags register if some other register is 0. Excellent. And we could also actually set this if the flags register itself is 0, which is kind of fun. Because these registers are all first-class citizens available to be manipulated by really silly things. Awesome. So now let's do this branch. And I called it branch im because there's an immediate value that's included as part of the instruction. Okay, so do we want to write a helper for this? Because this is actually a bit cumbersome, and I think the answer is yes. Let's say pub, not pub, let's make it just a private function, set flag. And it's going to be, yeah, register flag. And it's not going to return anything. It's just going to set it. Okay, this is better. This is better, right? We can just set this flag using a nice, simple function that we're going to reuse everywhere. Set flag, register flag, compare. Cool. Beautiful. And now we're also going to write a corresponding function called test flag, which is going to do the same thing, but non-mutable. Cool. And this is going to return a bool. And this is just going to be and not equal to 0. Right? So we're just saying, is this bit set in these flags, but we're doing it in a nice interface where when we're actually writing our code, we don't have to think about, what these individual bits are. So test flag. So if this bit's set, self dot plus equals x. where x is an unsigned number, so we can't jump backwards. This is actually not ideal. It would be nice to be able to have this be unsigned, be signed rather than unsigned, so we can jump backwards as well. So this is probably a case where we want to be able to say I8 instead of U8, right? We want this to be able to be... because then all of the, magic just works. And we could actually do this. Right? We could just come in, copy this, paste this. This is extremely doable. Let's see if we can just quickly fix this up. Now, the opcode value, that's okay, right? Because when we encode it, okay, so Rust reinterpret signed integer as unsigned, right? So this is somewhere where if I was writing C, I would reach for, if we have some like, if I have something like uint, let's say, uint 32 tx equals something, and I want to use this, say, you could int 16 t, you could say that it's what is it? It's like right. You could treat it. You can just go through like the C ringer of turning it into a pointer and then unpointering it as that thing, right? Like you can just reinterpret the bits as whatever the hell you want. It's cool. It's nice. I like being able to do it, and I don't know how to just work with it here. So Rust provides no implicit type conversion. That's good, using the as keyword. But I don't want to convert. I just want to reinterpret from LE byte. Perfect. Thank you so much. From LE byte. So so it'll be from LE byte. But I can't put it outside of, so I can put this outside of the inside of the match clause rather. From LE byte. That's kind of like the opposite of what I want. I'm going from a signed I8 to a unsigned U16, but I want the bits to be the same, right? This isn't... Oh wait, no, this is. Yeah, okay, no, you're right. So what I would say here is... Oh, but this already expects a U8. So what happens if I pass... So if I do this, for example, right? So let's say 0 U, right? What happens if this is an I8? It's not gonna work. How do I... This is the bit that isn't working. Going from an signed 8-bit integer to an unsigned 8-bit integer. This is what I'm struggling with. So this, once I have that, this is great. But how do I... But I don't even need it, right? Because this is just... This would be the same as saying... Like, Rust will just do this extension and fill out the upper 8 bits with zeros. To U8. Well, we don't even need the word signed here, right? Just I8 to U8. How do we do it? Like, there's got to be something really obvious here that I'm just missing. Or maybe I'm just, like, scared to try. Leading ones, trailing ones, U8. try, okay, hold on. Try from, converts a car into a U8. Okay. Try to create the target number, error if the source value is outside. So this is not what I want. I want the one that just does the gross reinterpret. This is also not what I want. As U2, silently overflow. Too primitive? For a type that doesn't completely fit. Well, for a type that completely fits inside the other. As byte. Hold on. Okay, that sounds right. Rust i8. Thank you very much for your help, Damon. Sometimes I just need this little push. That's not it. Is this as byte? But I've got to, how do I, like, this doesn't exist in i8, right? So i8 to BE to LE. Okay, this is it. Sorry, yeah. Okay, that makes sense. That is it. 2 LE bytes. And this, it feels kind of counterintuitive, right? But I guess it's just like the same shape as everything else. So, U dot 2 LE bytes. And this thing only has size 1, which is hilarious. But anyway, raw value 0. Yeah, no, thank you. Sorry, I just didn't even think to look for this method in i8 because it just doesn't make any sense, right? It doesn't make sense to me at all to cast this into some kind of like one element array. Like it feels silly. It feels very silly. Okay, now when we decode this, no, because we're going from a U16. Okay, so it's going to be the same problem. And so this has from LE bytes as well. Yes. Okay. I'm with it. So U8 from LE bytes, and this is just this thing. Everything that's in here with the correct mask. I always do this in Vim. I always paste one character out and then I just look silly. Also, that's one too many brackets. Wait, that's one too many brackets there. There we go. Okay. So now it looks okay. Parse numeric. I think parse numeric might have an issue because it only parses unsigned. Okay, so our string encoding is going to be a bit broken. VM instruction. Spelling is really hard sometimes. We also need to pull in this register flag to fix these compiler issues. I need to stop naming things plural. Like, this type is not this type contains all the register flags, but it is only each thing is only an individual register flag. And if that seems picky and abstract to you, you're absolutely correct. Okay, VM. Well, this is. Okay, no, this does blow up in here as well. Okay, we'll get there. I think I know what happened. That is good. Okay, I know where I went wrong in my macros here. It's because when I do my i8 stuff, I did not deal with this properly. I made the same error that I tried to do the first time. I caught it the first time, I didn't catch it the second time. Okay. I really need to get quick fix lists working for this, because this is a bit tedious. Parentheses around around assigned value. That's weird, I'll think about that. U81 cannot be dereferenced. This is also actually pretty simple. That's because I did that in a silly place, that's okay. Expected I8 and found U8. Expected I8 found U8. Yes, that's because I wanted an I8 there, not a U8. It's funny how these compiler errors are just kind of accurate. Expected I8 and found U8. Okay. Trying to unwrap. Cannot convert from U8 to I8. Yes. Yes, that makes sense. Why does that make sense? Oh, yeah, because of this, Apparently I can clean this up if I implement display for my my error type, which would be nicer than having to have this gross map. Okay, let's maybe just find parse numeric. Let's find this, and let's maybe copy and paste it in the worst possible way to make it parse numeric signed. Okay, and this is just gonna break a bit, but let's just see what happens. That's better. You can convert and panic. Cannot the where did this happen? Cannot convert U8 to I8. Okay. Oh, that's because I'm very silly. I'm really having a day today, aren't I? Right? Because I did that work, but then I forgot signed. Really not my best day. I'm not on my A form. That all looks good. That looks like we've fixed the macro hell, which is going to continue to bite me. A field registered. I forgot an S. That's excellent. I love it. Where was it? 1, 2. Yeah. It's hard remembering line numbers. Mismatch types. Expected result 126. That's because this is just okay. And so is this. Regardless of the if statement, it's all just fine. Okay, now cannot add assign I8 to U16. Oh, what does this mean? What this means, so we have an I8. Well, actually, we have the program counter already, so we could just say PC, maybe plus, and now this is going to be more explicit about what's gone wrong. We can't add these things together. How do we... Rust add signed U8 to U16. I guess it's signed I8 to U16. Because we could underflow, right? So we have to be kind of explicit about what that underflow means. Wrapping add signed. Ooh, Rust. Wrapping add signed. This is cool. Wrapping add. Yeah, okay, so let's look for U16. It's going to be the same as U32, but let's just wrapping add signed. Oh, this is excellent. This is excellent. Let's just do this. So let's say pc.wrapping add signed. So we just have to be explicit that there could be some type jank here. We are shouldering this. We're gonna handle it, and we can upcast that. That's okay. Okay, so some unnecessary parentheses. Branch register not covered. That's also fine. We can just implement this real quick. So let's copy and paste, in fact. And I love that this is a compiler failure when we forget to implement an instruction. Branch register. Okay. So now this is a lot simpler because now we just say sorry. As usize, right? We just assign. We don't have to do any of this type casting silliness. It all just works because all our registers are U16s. But this is really cool. I like that Rust makes you be explicit about this, even though it's a bit tedious and it's hard when you don't know exactly what you're doing. This is good. Okay, so let's write some code that branches. And this is going to be hard when we're manually calculating the branches ourselves, but we'll do it for now, and then we'll think about what an assembler that was more automatic looked like, right? An assembler basically with labels. Labels are fun when you have to branch relative, but we can do that, right? We're smart. That's fine. That's fine. Okay, so test branch. All right. So what's that program going to do? What's that program going to do? Branch if a register is 0. So that's easy because all our registers start at 0. So let's actually just say this outright. So let's say branch im. Let's jump over. Let's do something simple, right? Let's jump over one instruction. So let's go push 42. We'll do this in decimal because the output's in decimal. 12 pop register A. And let's maybe use a different register just so that we catch anything that's coming up. Because we didn't catch our register encoding being incorrect before because we were only using the A register. Cool. So this is a simple program. The first thing we're going to do... No, sorry. The first thing we're going to do... We're going to test if the register B is 0. If it is 0, we're going to branch. We're going to skip over an instruction. So what ends up... Actually, wait, no, this doesn't work, does it? That was silly. We're going to... We're going to skip over 2 instructions. That we expect the A register to be 0. That was a bit silly of me, but that's okay. That's okay. These things happen. It's one of those days, apparently. Cargo run bin. We'll ignore these for now. PC read fail. Okay, so we didn't halt. We didn't terminate. What went wrong? Interesting. So this program is full of nops. It runs through the entire memory space just executing nops. And this is a good argument for why nop should not be opcode 0 because it's a really quiet default for when things go wrong. So branch.prog. Okay, this is an empty file. Interesting. Why should I say branch.prog? Warning, warning. I made a typo. Sorry, I didn't read the output of my program. Brack branch. Okay, now we're all good. And now it just runs. So what do we say? If 0, we see that flags actually get set. And then we branch. Our PC goes from 4 to 8. So we do not... we skip something. Our PC goes from 2 to 6 here. Sorry. So this is printed after the instruction run. So our PC 0, 2, this is instruction 4, but afterwards our PC is 6, 8, 10, 12. Okay. So we're not skipping enough. We need to skip another instruction because that's a little bit gross. I need to think about why this is not the instruction I think it is. But anyway, now we can see that we never we never execute some of this program. A is still 0 at the end. That's beautiful. That's what we expect. I'm just going to go to the bathroom really quickly, and then I'm going to come back. We're going to do a few more quick things, and then I'm probably done for the day. All right, back in a sec. All right. All right, let's do a few more quick things, and I gotta go to the hardware store. It's gonna be a fun day. It's gonna be one of those days. Okay, let me just make sure everything looks correct on my end. It does. So we can branch. We can do some fun stuff with this. We can start to write real programs. And I think an important part of writing a real program is gonna be to have, actually, okay. Let's just add some stuff. Everything except cargo.toml, really. I feel like just with this instruction set, we probably can do a shocking amount of things. But, you know, there's more needed. There's more we really need to get particularly useful. One thing that we probably want to be able to do is assign a register to another register. Now, I have thoughts about this, but maybe we just say, maybe we really do just make it like opcode 4. Okay, we're gonna do a quick cargo build. Excellent. This tells us exactly what we need to add. typing the wrong thing. That's hilarious. I called it register set, right? Set register. Well, let's call these source. Set register. We'll call them R. Well, I'm just gonna call them A and B. That's fine. That's fine. Okay. And all we're gonna say is self dot registers are A as usize. A B. Yeah, it's source target. So equals self registers B as usize. So we just set A to B, and everything is A-OK. This is a cool instruction. This is gonna be a little bit useful. Excellent. Push register, pop register. Excellent. Excellent. Now, the next big thing to tackle will probably be maybe starting to get into some calling convention stuff. Push, pop. There was another thing I really... Oh yeah, of course, reading and writing to memory. That's going to be pretty important as well, right? It's going to be relatively important, and we can write a really cool test for this. So let's... I want to keep my commits fairly atomic. Let's add these wonderful instructions for reading and writing memory, and we're going to call this let's go opcode. That's the wrong bracket. Let's call it load and store, I guess. Load and store. So load, now we have to be very clear about what these mean. Load register. Let's say load register. Load a value from memory into a register. We take one register as a target. Now this is tricky, because what does this mean, right? What does loading a register actually mean? And this is a good question. Let's start with the simpler thing, which is loading to the stack, because we can actually take... Ooh. Okay, this isn't as obvious as I thought. Because our memory is 16 bits, how do we actually get a 16-bit address, right? So the obvious thing is to load it from a register, but which register? Now we have this cool register called M. And M, my idea was that this would be kind of like the memory register. It would impact our reads and writes. Because I've been thinking about actually expanding this to a 32-bit address space, this gets a little bit trickier, because I was hoping to be able to use M sometimes as some kind of banking register. But actually, we could add another banking register in addition to this as well. We could also just make these different instructions. So let's actually do this. Let's say load A. We're going to take a register which has an address in it, and that... Let's say load A register. And load a immediate, which is going to be a U8. Okay, so these will be things that get added to some kind of bank at some point. Cool. This will make sense in a second when I implement them. And we'll copy and paste this for B and C. Damon says, if my memory is 32-bit, I can have a separate high and low register. I'm not gonna do that. I am gonna keep all of my registers just 16-bit. But you can think about it as like a high and a low register. And in this case, this is what I'm gonna do at some point. I'm gonna make it optional. I might actually make it controlled by a flag in flags, but M in some cases will be treated as a bank. So that will be like the high register of whatever register you pass here to read from. Cool. So load A, load B, And that's interesting as well because where you choose to put that bank will be interesting, right? Because yeah, you can only access half of it with an immediate, right? You need to use a register to access the upper half. So, you know, maybe there'll be some like fun holy memory things. I don't know. I like having an instruction set that is a little bit odd and that will require some creativity to fully harness. But maybe that's just me. Maybe that's just my weird, you know, maybe I just enjoy the suffering and the pain too much. My PlayStation 2 days have really changed me. Okay, let's copy and paste these because I don't want to type the word a bunch of times. Okay, but anyway, yeah, for now my memory is still 16-bit, so it's a bit of a moot thing. We're just gonna basically skip part of that. Push register, set register, so let's dump it here. We're gonna grab all of this. We're gonna actually do that better. We're gonna say shift over by 2. Excellent. Cool. Cool. We can now use that macro I just recorded. I'm really enjoying Vim macros, even though I'm a bit of a noob with them still. Okay, so load a register. What we're gonna say is let read, let b, let w for word equals self dot. Now, what is this? Self dot memory dot self.memory dot read 2. Easy. Read 2 because we're reading a whole byte. Actually, that's a little bit confusing calling that A, isn't it? Because A is the name of a register. Now, how do we unwrap this? It's an option. So let's maybe say match. If we get some x, then we say self.registers register A as usize equals x. And we're okay with that. But then we need to wrap it all. Yep. Okay, there we go. Otherwise, if it's nothing, we're gonna... and I think this still takes a string, right? It does. Cool. And we're gonna have to copy and paste this a bit, but that's okay. That is okay. We're gonna do the same thing for B, however... And again, you know, we could kind of make this a method, I guess, and maybe we should because that might be easier, but for now let's just copy and paste and see how some of these instructions start to shake out before we decide where our best reuse points are. Cool, register C. And then the immediate is going to be very similar as well, except instead of having to read a register, we are just going to use the immediate. This is A. Cool. Load B immediate. We're going to dump this here, register B. And then we are also, I need to copy and paste it again, gonna dump it here. Cool. And yeah, again, because we only have this 16-bit address space, it's gonna be fine. It's gonna be fine. Excellent. Excellent. What happens if I cargo build this? Is it okay? It's pretty close to okay. I missed some very silly things. That's okay. This happens. This very much happens to me. I just need to dump my little arrow. That's all good. Just always the little things you forget when you're working in a new language, or when you just swap languages a lot, really. That is also great. We love this. We love this. This happens to me, again, in languages where semicolons are not needed after every line, where some lines are expressions and some lines are statements. A little bit tricky. Okay. Adder not found in scope. That also makes sense because... Oh, well, I also didn't do this. X. Sorry, B. And then this needs to be R. So, yeah, this is just like the result of lazy copy and paste. B. Okay, so that is good. This needs to be updated. This is why copy and paste can get really, really tedious. You got to be careful. You got to be careful. And this is R, and then this is B. Okay, flags. That's a warning, which is great. Expected result. Expected result. What's this? Expected result found set registers. Ah, crap. I swear I ran a cargo build after that, but sure, whatever. That's fine. Okay, read expected U16 found U8. That is also fine. We just need to update all of these now because copy and paste. Excellent, we love this, we love this. As a U16. Let's do this in Vim so we can scroll around easier. Warning, warning, perfect. Okay, that's excellent, that's excellent. So, what do we do with any of this? Well, we can load things from memory, right? The only interesting thing we have in memory right now is code. But we can do that, right? So let's write let's write a program, push21, right? And we know that push21 is gonna just be 2101, right? We know that this is a known bit pattern. This is a known bit pattern. So if we maybe do and let's make this hex 99, right? So we know that this is gonna be 9901. Okay, okay. So if I load 0, 1, 2, right? If I load 2, 2. Actually, no, I don't need to do that. I can just say load. I can say load, let's say load B im 2. 0, 1, 2, right? So load this byte into the B register, and then we're just going to say add stack pop register A. So we want to see the sum of these things in the A register, and we want to see this value in the B register, and then we're just going to say signal. Excellent. Let's see what happens. This needs a file extension. This is good. Okay, what is this in hex? This is the $1,000,000 question. 39169 9901. So we load the correct value into the B register. We load the correct value into the A register. That's more just like a sanity check, I guess. Cool. So that appears to work. That appears to work. That's not a very thorough test. Indeed, I think the theme of the next stream should be writing much better automatic test cases. Let me do. So let's just quickly. add load from memory instructions. They're going to get more complicated as time goes by, but that's okay. Git add source bin dis. Cool. Apparently I'm still in branch main. I thought I created a new branch. I created a new branch, but I forgot the flag to swap to it. Excellent. So this is all just going in main anyway, which is great. Let us create a tag called Z2024-01. What's the date today? Is it the 25th? Man, this year's flying by. Cool, I'll push that up in a sec, and then people can go look at it. But yeah, I think more tests, more automatic tests. Oh, no, sorry, hold on. I forgot. Oh, actually, the clippy stuff I haven't dealt with yet, but yeah, cool. Yeah, I should have done this before. Well, I haven't pushed the tag yet, right? So git I'm just gonna like delete the tag and then recreate it. Delete git tag DZ2024-0125. Yeah? Now I'm gonna just retag this new commit, and then we're going to push in a sec. Okay, excellent. Thank you very much for tuning in. This has been a bit of a sloppier stream. I will think a little bit more about my instruction set and how it's going to work. But maybe I'll just like get some pen and paper and draw it out on stream or something. People can watch the whole design process, because how I use this space is going to be interesting. I really don't have that many opcodes so far, and I don't think I'm going to add too many more. Maybe. There are a few things that I want to do to make it easier to work with this kind of 8-bit, 16-bit difference, because loading immediates is annoying. But we'll see how we go. I think there are some things that are quite fiddly that I need to play around with. Anyway, this has been a fun stream. I've enjoyed it. I'm enjoying doing this. I'm hoping to do a lot more. I'm probably going to be moving to Twitch at some point very soon. Because I think it's going to get me more viewers than YouTube, but that is still something I'm thinking about. Thank you very much for tuning in. I'm Tom, and I will catch you